I'm Anil Kumar, and here is question number 5. The question is, sketch graph of function f of x equals to minus of absolute minus 1 plus x plus 2. You can pause the video, sketch the transform function, and then look into my suggestion. Now, as I've been saying, if you are having a function like this, it is a good practice to write it in standard form. So standard form for me is f of x is minus. Now within the function I'll write x first, right? So it is kind of clear to me, x minus 1 plus 2, right? So that is how the function is, right? So now here we have vertical reflection. Horizontally the absolute function has been moved 1 unit to the right and 2 units up. Now there are a couple of ways to draw the transformed functions graph. One of them is to consider the key points, right? So the key points on absolute x are, let me write x and y values, and then we'll write those transformed points on f of x. So on absolute x, the key points are minus 2, 2, minus 1, 1, 0, 0, 1, 1, and 2, 2, right? So these are the key points. Now if you notice, since we have vertically reflected and 2 units up, the y points become minus of the y value plus 2. As far as the x points are concerned, they will be translated 1 unit to the right, so the x points will have x plus 1 as its value. So if you apply this transformation, then the image points should be, let's add 1 to the x values, and let's do first adding 1 to the x values. So if I add 1 to x values, I get minus 1 here, 0 here, 1 here, 2 here, and 3 here. So that is the change in the x value. As far as the y values are concerned, negative of these numbers and then add 2. Negative 2 plus 2 is 0. Negative 1 plus 2 is plus 1. Negative 0 is 0 plus 2 is 2. Negative 1 plus 2 will be 1. Negative 2 plus 2 will be 0. So these are the transform points, right? So now once you have these transform points, you can always plot these points on the graph, right? And get your answer. So you don't even have to plot your original function at all, right? So that is one way of doing it. Now here I will show you graphical way of doing it. That is, let us say we have this absolute function. Okay, so let's say this is my absolute function where my points are 0, 0, and let us say this is 1. So at 1, 1, right? And let's say at 2 we have a point which is 2. Okay, so let's say this is my point 2, right? Now reflection on the y-axis means it will bring these points down here, right? So it gets reflected. So the graph will be kind of like this. So that is because of minus absolute x, okay? And then we are translating it 1 unit to the right and 2 units down, correct? So we could do a couple of transformations here. That is, we can translate it 1 unit right first, right? So we get this. So this is minus of absolute x minus 1. And then 2 units down. So finally we'll get a graph which will move it 2 units down. So 2 units up it is. So 1 and 2, so it will be 2 units up. Then we get our final graph, right? So which will be kind of, I don't have real graph paper, so the vertex you can see is at 1 and 2, so that becomes the vertex 1 and 2, and this point will move to 0 and 1, so this is 0 and 1, and then 1 and 2. At 1 we'll have a value 2 which already we have, minus 1 and 0, minus 1 and 0. So these points get connected. and kind of like this. Do you see that? So this will be going through 3. So that is the kind of absolute function which you will get on a graph paper. You'll get exactly the same values, right? So either you could do stepwise translation or stretch and compressions. In this case, it's only reflection and translation. Or you can get these points, plot them, and find your answer, correct? So I think this is a very good approach, especially when the function is complicated. I hope you appreciate it. Thank you.